All right, last topic here is going to be stars. So stars are classified based on their properties. Some properties of the stars that we care about are luminosity, color, and temperature. Luminosity is probably the most unfamiliar word on that list, and it's just another word for how bright the star is. Now, the most important thing to understand about this, stars may be brighter than the sun, even though we don't see them as brighter. That's the biggest difference between it and brightness. It's how bright it is, not how bright it appears on the Earth. So if we were closer to those stars, they may appear brighter. Color just is as simple as it is. It's the color of the star. Now, we originally just were able to do the color, but at a certain point, someone really smart figured out that the color of the star is directly related to its temperature. Hotter stars are closer to the bluer side of the color thing, and redder stars are not quite as hot, actually. So, temperature is how hot the star is, and it's related to the color. So this is a common chart. This is in your ESRTs, and it's in a lot of other places. It's called an HR diagram, named after the two people that came up with it. And all stars, based on their luminosity, their temperature, and their color, they're going to be at a different point. So we can find our sun right here. It's got a luminosity of 1 and a surface temperature, around 6,000 Kelvin, and it's yellowish. Now you'll notice that things get more red as they go this way, but we figured out after making this diagram a long time ago that it's actually that's opposite, that the things to the left are hotter, so the temperature scale goes the other way. You'll notice that your highest temperature here, 30,000, is on the left side instead of increasing the way a normal graph does. You'll also see that there's different groups of stars. There's this main sequence, and that refers to these kind of stars in the middle. That's like the normal place that a star ends up. We can also see these white dwarfs down here, and our giants, which are here, and then in addition we have our supergiants all the way up top. So we can fill in some of the information here. Things like 10 times around this, that's likely to be a red giant. Things end up there because they're no longer burning hydrogen. A small bright star, that's just a dwarf. Average stars are on what we call the main sequence. A supernova, that's just the death or explosion of the star. It gets really bright for a bit, and then it decays into something else. So they don't last for very long, so we don't put them on the main or on our diagram because we don't really see very many of them at one time. But we will see some black holes. That's just the remnant of a star where it's collapsed and it's so strong that nothing can escape from there. So the stellar life cycle diagram is going to help us describe how that happens, where we see these different things. So we start off with a stellar nebula over here. So a nebula is just where they start. And things collapse into that stellar nebula. Eventually things get close enough together that hydrogen starts burning out into helium. So we start to see something there. And depending on the size, it can either become an average star here, or it can become a massive star. Now, massive stars are just going to be higher luminosity. They're going to be brighter. After it goes on to be an average star, it might start to explode. It's no longer burning hydrogen to helium. It's burning heavier elements. And at that point, we would have a red giant. Now, if it was a massive star, similar type of thing going on, but because it's so much bigger, we're not going to call it a red giant anymore. We're going to call it a red supergiant. Now, after that happens, after we have the red supergiant, that might form a supernova. So things are going to explode, and we're going to see something really bright, and then it's going to become a neutron star or a black hole, depending on how big it is. Whereas red giants, they're more likely to, just become planetary nebula. So similar to a stellar nebula, but just a place where planets grow instead of where stars grow. And then after it's made as many planets as it's going to make, it might end up being a white dwarf, which is just a small bright spot.